In this example, we are going to demonstrate how lockless optimistic concurrency control works in JSON Duality view. Here are some relational tables that we will use for this example. Optimistic concurrency control are used to prevent data inconsistency that can arise due to read-write conflicts. Transactions and locking can be used in environments using connections, but these mechanisms do not work across stateless REST calls, as we will demonstrate. So let's say we have a patient's application that uses a REST operations to view the data from a patient's JSON Duality view. For this reason, let's build the first JSON Duality view. Let's execute it. And then let's say the patient one application uses a REST GET operation to read the state of the patient, which is equivalent to a select statement. And this is what the user application gets in the JSON form. Now, simultaneously, let's say there is a doctor's application backed by a doctor's JSON Duality view, like this. And the doctor also issues a read request via REST GET to see the state of the doctor's JSON. Note that both doctor and the patient share an important information, which is an appointment between the two. Now, here's the problem. If the patient wants to change the appointment with the doctor, then the patient will issue a GET put request or an update. And let's say we want to update the JSON, and we can directly change the appointment time. So the patient wants to postpone the appointment with the doctor. We run that, and the appointment from the patient perspective has been delayed. What if the doctor wants to also make some changes to the same appointment? If the doctor issues an update statement from his perspective, let's say the change with the same patient, that was patient one, the doctor wanted to make the change to A update. If the doctor actually issues this query, this will overwrite the changes that has been made from the patient's perspective because there was no locking done across the two REST operations. However, if the doctor executes the statement, we see that there is an error. This is because the JSON Duality view uses an optimistic concurrency control to prevent read-write conflicts. So how does this work? The mechanism is based on the hash called ETAG, which basically serves as a fingerprint of the doctor's object, JSON object. So when the doctor read the object, the same ETAG was delivered in the update statement. However, between the two updates and read, the patient has already changed the state of the appointment in the database. So that means the database has a different ETAG what the doctor was about to change. This mismatching ETAG basically prevents any read-write conflict from the doctor perspective, and hence the update from the doctor side is rejected. So what can the doctor do? So for this, the doctor's application has to reread the data again, fresh from the database. And this time, the doctor can see that after rereading, the ETAG has changed and the appointment has also changed to the 10th. Based on this state of the data, the doctor can decide if he or she still wants to make an update. And in that case, it can issue a new update query using the fresh ETAG, and the update to the appointment can be done maybe on the 8th. And then this time, when the user executes, the query is successful. So that demonstrates how the luckless optimistic concurrency control in JSON Duality view can be used with applications to avoid read-write conflicts, even in stateless REST environments. Thank you.